All right, so we're going to do a quick review of what we know. A quick review of what we know. So far we've done mass to mole conversions, mole to mass. So you don't have to copy any of this down. We're just doing a quick review so you can watch. So if I have 4.2 grams of carbon dioxide, I calculated that carbon dioxide is 44.01 grams to moles, grams per 1 mole. I added up 12.01 for 1 carbon and 32 for 2 oxygens at 16 grams per mole each. That gave me 44.01. So if I have 40.2 grams, how many moles is that? I'm going to put my grams on the bottom so that I can cancel them out. And I'm going to put 1 mole on the top. So 44.01 grams per mole. I'm going to flip that, 1 mole over 44.01 grams. When I divide 4.2 by 44.01, I get 9.5 times 10 to the minus 2 moles of carbon dioxide. We could also do this the other direction. We could say 3.7 moles of carbon dioxide, and I want to know how many grams that is. So using the same molar mass, grams per 1 mole, up here, grams per 1 mole, I put mole on the bottom. That way I can cancel out my moles of carbon dioxide. And I'm going to multiply across the top, which gives me 2 digits because of the 3.7, 1.6 times 10 to the 2. Next, I'm going to do moles to particles, which is what we also did. Now, particles could be atoms, they could be molecules, they could be formula units, moles to particles. And that's 6.02 times 10 to the 23rd particles to 1 mole. So here it is, molecules to 1 mole. So 4.3 moles of carbon dioxide. 1 mole of carbon dioxide is 6.02 times 10 to the 23rd molecules of carbon dioxide. So I can cancel out my moles. And I'm left with 2.6. Notice my 2 significant digits because of my 4.3. So 2.6 times 10 to the 24th molecules of carbon dioxide. I can go in the other direction, and this time I used atoms. So 1.6 times 10 to the 21st atoms of carbon. My atoms go down. So 6.02 times 10 to the 23rd atoms, particles, atoms, to 1 mole. So now I can cancel out my atoms of carbon. That leaves me with 3.26. Notice my 3 digits in my answer because of my 3 here. So 3 digits in my answer times 10 to the minus 3rd moles of carbon. The last one is the one that we learned on Friday. That is volumes to moles. So volumes to mole is liters to moles or moles to liters. And the conversion is, in case you've forgotten, is 22.4 liters to 1 mole. All right. So this is only for gases at STP, standard temperature and pressure. So if I have 14.5 liters of O2, I'm going to put my 22.4 liters on the bottom so I can cancel my liters, and that'll leave me with moles on top. When I divide that out, I get 6.47. Notice the 3 digits here and the 3 digits here, times 10 to the minus 1 moles of O2. Now over here I have 9.1 moles. What I want is how many liters. So my moles of O2 go down and 22.4 liters of O2 goes up on top. When I multiply that out, I get 2.0. Notice 2 digits here and 2 here times 10 to the 2 liters of O2. So those are the 3 things that we've learned now. So you can go back and review them if you want. But today we're going to put some of these together and we're going to do multiple step conversions. All right, so we're going to start with multiple step conversions. The first problem we're going to start with is how many molecules are in, so I'm going to have 13 grams of NO2, 13 grams of NO2, and I want to know how many molecules that is. So according to our mole tool, which you should have put on your periodic table, we are starting with grams here, right? We're starting with grams and we want to go to molecules. So the only way to get from grams to molecules here is to go through the mole. So we're going to go from grams to moles and then from moles to molecules. And that's the path we're going to take. Grams to moles, moles to molecules. So to go from grams to moles, we're going to use the molar mass. So I'm going to add up my molar mass here. So I have 1 nitrogen, so that's 14.01, and I have 2 oxygens, so that's 32. 2 at 16 each. So that's 1. So 46.01 grams per mole is my molar mass. So I'm going to start with my 13 grams of NO2, and my first stop is going to be to moles. So 46.01 grams of NO2 is equal to 1 mole. Now, if I wanted to, I could stop here, run this calculation, get an answer, and then I could start down here and say, now I'm going to go from moles to molecules, right? And then I would say like 1 mole, however many moles of NO2, 1 mole of NO2 is equal to 6.02 times 10 to the 23rd molecules. But what we can do instead is we can just sort of keep going. And we can say, okay, so if I have this and I've canceled out my grams, I'm left with moles, whatever that calculation is. And so now I'm going to say that if I have 1 mole of NO2, that is going to bring me to 6.02 times 10 to the 23rd molecules of NO2. So now I can cancel out moles of NO2, and I'm left with just molecules. So according to my mole tool, I went from mass to moles, and then from moles to molecules. So here it is. I went from mass to moles, and then I went from moles to molecules. Now, when I do my calculator work on this, it's going to look like this. I'm going to take 13 times 6.02 E23 equals divided by, and then it says answer, right, 46.01. So that gives me 1.7 times 10 to the 23rd. So that equals 1.7 times 10, notice my 2 digits here and 2 here, to the 23rd molecules of NO2. All right, so that's how we get there. Now, what if I wanted to go from, let's say, 3.67 times 10 to the 21 molecules of NO2, and I want to go to liters. So I look here, I want to know how many liters is that going to be, because NO2 is a gas. So how many liters of gas will that many molecules be, right? So I look here, I'm at molecules, and I want to go to liters. So I want to go to volume in liters. So I've got to go from molecules to moles, and then from moles to liters, 2 separate conversions. So first, I'm going to go from molecules to moles. One mole. And now I can cancel out my molecules because one is on top and one is on the bottom. And now I'm in moles. So now I'm just going to go from moles to liters, just like you did on last night's problems. So 1 mole of NO2 is 22.4 liters of NO2. Now I can cancel out my moles, and I'm left with the unit of liter, which is what I want. So now my calculator work on this is going to be 3.67 E21 times 22.4 equals divided by 6.02 E23rd. So I get 1.37 times 10 to the minus 1, and then liters of NO2. All right, so all you have to do is say, I need to get, use your Moulton map, I need to get from one place to the other, and you're going to have to go from the moles in between, right? Now, what if I were to tell you that you had not grams of carbon dioxide or grams of methane? So methane, let's say I have 126 grams, kilograms of methane, right? And I want to get to molecules. Molecules equals how many molecules? Now, when I look here, I know I'm going to have to go from mass to moles and then from moles to molecules. Okay, that's fine. But the problem is my molar mass isn't in kilograms. It's in grams. So the first thing I'm going to have to do is I'm going to have to take my 126 kilograms of methane, right? And I'm going to have to go from kilogram to gram. So kilo is 10 to the third. So kilogram, 10 to the third grams. And now I can keep going. So now I'm going to take one carbon, which is 12.01, and 4 hydrogens, which is 4.04. So when I add these together, I get 16.05 grams per mole. And that's for methane. So now I'm going to cancel out my kilograms, right? And I'm going to go grams of methane to 16.05 grams of methane to 1 mole of methane. Okay, so now I'm in moles of methane, canceling grams of methane, and now I'm going to go from moles to molecules. 1 mole of methane, 6.02 times 10 to the 23rd molecules of methane. And now for the math on this, the calculator on this, so I'm going to have 126 times 1E3 times 6.02 E23rd equals divided by 16.05. 4.73 times 10 to the 27th. Molecules. There we go. CH4. Okay, so that's another one. That's another thing that you might have to convert from units before you can even keep going. Okay, so let's take a look at a word problem. You have a couple word problems. They're not real challenging on your homework tonight. So here's an example of a word problem. The beaker, so this really should be a beaker. A beaker of water holds 173 milliliters of water. How many molecules of water are in the beaker? Okay, so let's see. We could go from liters to molecules, except this is not a gas. Water is not a gas. So this would be gases only. So you cannot use the 22.4. I know you want to, but you can't, all right? Because it's liquid water. So that means the only way to get there is from grams to moles and then moles to grams, moles to molecules. The problem, of course, is we have milliliters of water. But fortunately, Miss Paxton has made us memorize the density of water. And so we all know what it is. What is it? Boy, I hope you said 1.00 gram per milliliter. I hope so. Okay, here we go. 173 milliliters. And so the first thing we want to do is convert to grams. 1 milliliter of water is equal to 1.00 grams of water. See how easy that is? Okay, then that gives, now we're in grams of water. So now I can just keep going. So I need the mass of water. So 2 hydrogens is 2.02. And then 1 oxygen is 16. So that adds up to 18.02 grams per milliliter. That's the molar mass. That is not the density. I want to be clear. That is the mass of 1 mole. Sorry, my mistake. That's the mass of 1 mole of water. This is the mass of 1 milliliter. 1 milliliter does not hold a mole of water, okay? That's a whole different problem. What is the volume of a mole of water? All right, here we go. So grams, so we say 18.02 grams of water to 1 mole of water, and we want to know how many milliliters that is. So now we're just going to go to milliliters. Molecules. How many molecules? So now we're just going to go to molecules. 1 mole of water, 6.02 times 10 to the 23rd molecules of water. Okay, so now the calculator work on this. Of course, you don't have to put in that 1, right? So 173 times 6.02 E23 divided by 18.02. So 5.78 times 10 to the 24th molecules. 5.78 times 10 to the 24th molecules of water. So kind of an interesting question. How much volume would a mole of water take up? Well, let's see. So we need to go from a mole of water to volume. So that would be going from here to grams, and then we can use that 1.00 grams is equal to 1 milliliter to get to milliliters, and then we can convert to liters. So, you know, I mean, we know that it's definitely not this, because this is 1 gram to 1 milliliter, and this is 18.02 grams to moles. So let's see how much it is. So we want to know if I have 1 mole of water, and let's say 1.00, just so we get some significant digits in there, right? So 1 mole of water is equal to 18.02 grams of water. Now we want to get to milliliters because we're looking for volume of water, right? We're looking for how much, what volume is that mole going to take up? We know that 1 gram is 1 milliliter. But how many milliliters or how many liters is 1 mole? So 1 gram of water is equal to 1 milliliter of water. Oh, well, that's nice. Okay, so let's see how many milliliters it is. Oh, look at that. 18.02 milliliters. That is the volume that 1 mole of water will take up. All right, so 3 digits, 18.0, right? You can't see that. Sorry, there you go. Okay, so that's the volume, 18.02, right? Makes sense. Since 1 gram is 1 milliliter and 18.02 grams is a mole, then 18.02 grams would be 18.02 milliliters. All right, so you should have enough information to get your homework done. And you can get started right now and get it finished up for tomorrow. Both pages, 3 and 4. Yep, should be able to do that. Get started. Don't waste this time. All right.